Sequences. Write down the first 5 terms of the sequence. So let's take a look at A here. A says A sub n equals 2 to the n plus 1 over 3 to the n plus 2. So the idea here is, if we want to write down the first 5 terms of this sequence, we have to realize that a sequence is just a list of numbers. So A1, comma, A2, comma, A3, comma, dot, dot, dot. So that dot, dot, dot means it just keeps going. And what we're going to do here is we're just going to list the first 5 terms of this list of numbers. So to do A1, for instance, here, and usually that's where we start at. We could start at A0, we could start at A4, depending on the sequence that we're dealing with. So first off, if we're going to look at A1, I write A1 down, and this 1 here means that I'm going to plug in a 1 wherever I see n in my sequence. So that means this first one is going to be 2 to the 1 plus 1 over 3 times 1 plus 2. So then for the first one here, that's going to be 3 over 5. So then for A2 is going to be 2 squared plus 1 over 3 times 2 plus 2. And that's going to equal 4, 5 on top over 6, 8 on the bottom. So there's our second one. So that A3, that's going to equal 2 to the third plus 1 over 2 times, 3 times 3 plus 2. And that's going to equal 8, 9 on top over 9, 11 on the bottom. I'm just going to continue this process down to A5. And we get the rest of these problems this way. One thing I want you to notice here, when I have this 2 to the n plus 1, we can see that it actually grows faster. So I went from a 3 to a 5 to a 9 to a 17 to a 33. While the other expression on the bottom here, the 3 times n plus 2, was 5, 8, 11, 14, and 17, which is only rising by 3 every time. So eventually the top is going to be much larger than the bottom. So those are things to understand too when I'm dealing with these sequences. So I'm just going to write these at the bottom. So all of this together would be a complete answer. And do realize though that this does keep going on and on. But again, this problem just said the first 5 terms. So let's try number B now. So one thing to understand about B first is, do you know what factorials are? So I'm just going to give you a crash course in those first. So let's take a look at 4 factorial. So 4 factorial means it's 4 times 3 times 2 times 1. So 4 times 3 is 12, plus 2 is 24, plus 1 is 24. So my answer for 4 factorial is 24. Another one to make note of is 0 factorial. 0 factorial is 1. So that's just understood to be 1. Just so you know. So we can have a 0 factorial on the bottom, and that's fine. So there's your crash course. So in dealing with this sequence, I'm going to take B1, and B1 is going to be 1 factorial over 1 minus 2 factorial. And that equals 1 on top. But notice the bottom here, I end up with a negative 1 factorial, which is not a number here. So therefore, I can't start at 1. So I actually have to start this sequence at B2. I can't do that one. So then B2 is going to be 2 factorial over 2 minus 2 factorial. So then on the top, I get 2. And on the bottom, I get 0 factorial. I'm just going to write that out to show you. And that will equal 2 over 1, which is 2. So there's our first answer for B2. And that's our first term in this sequence. So now for B3, this is going to be the second, we're going to get 3 factorial over 3 minus 2 factorial. And that's going to be 3 over 1, no, 3 times 2. I'm just going to write this one out. And that'll be over 1 factorial, or I should just say 1. And that's going to equal 6. Okay, and then B3, or B4 I should say, that's going to equal 4 factorial over 4 minus 2 factorial. And then on top, that's going to be 4 times 3 times 2 times 1 over 2 factorial there, because 4 minus 2 is 2. So that's 2 times 1. So that's going to be 12. And again, I can think about this canceling process before I actually multiply. And that's a big thing to help me to simplify these factorials a lot faster. Just understanding that. So then B5 is going to equal 5 factorial over 5 minus 2 factorial. And that's going to be 5 times 4 times 3 times 2 times 1 over, and that will be a 3 factorial there. So that would be 3 times 2 times 1. And then I can see that those cancel out, so I just get 20 because that's 5 times 4. And then B5 or B6, that's going to be 6 factorial over 6 minus 2 factorial. And that's going to be 6 times 5 times 4 times 3 times 2 times 1 all over 4 factorial. 6 minus 2 is 4. So 4 times 3 times 2 times 1. And I realize that those all cancel out as well. So that's just going to be 30. So there's my first 5 terms. But again, this one started at B2. So I don't necessarily always have to start at the first one, A1, B1, C1, and whatever you want to call it. So that means my list of numbers here are going to be 2, 6, 12, 20, and 30. And that's going to be my list, my first 5 terms. Now again, remember that this does keep going on, but for this one, it only asks for the first 5 terms. So let's move on to C now. So this says A1 equals 1, A2 equals 1, and AN equals N plus 1 plus AN plus minus 2, excuse me. So like I said before, this is a recursively defined sequence because it relies on the previous terms of the sequence. And we'll see what that means in a minute. So recursively defined sequence. So when I look at this one here, this is how this works. So A1 and A2 are already given here. So I'm going to start with A3 here. So A3 equals, and again, this is my formula here. So this would be A3 minus 1 plus A3 minus 2. And that means I'm looking at A2 plus A1. Okay, so then that would mean that I would be looking at what is A2 and what is A1. So A2 is 1 and A1 is 1. So that means it's going to be 1 plus 1, which equals 2. Now again, to rely on those previous terms means I have to have previous terms to begin with. So that's where the recursive part comes in, because I have to use something I already have. So then A4 is really going to be A3 plus A2, and going through the same process I did up here. So then that's going to be A3 is 2, because that came from here. So that's going to be 2 plus 1, which is A2. And that's going to be 3. And then A5 is going to be A4 plus A3. And hopefully you see the pattern here. So this is going to be 3 plus 2. I'm just using the previous two terms in sequence there. So that's going to be 5. And then I was going to write A5, but I already have A5. So A6 is going to be A5 plus A4. And that's going to be 5 plus 3, which is 8. And that's not quite 5 yet for me because I can't count the first two. They were given to me. So I'm going to do one more. So A7, so that's going to be A6 plus A5. And that's going to be 8 plus 5, which is 13. And I can keep going through this process here, but I don't need to. I just need to do the first 5 terms. So my numbers are going to be 2, 5, 8. Oh, I missed one. I missed 3. I knew something seemed weird there. 2, 3, 5, 8, and 13. Now again, like every other sequence, they keep going, but we only needed the first 5 terms here. Now this sequence is actually a very famous sequence. It's called the Fibonacci sequence, which these come up in many applications. One that I thought was pretty cool was the Pascal's triangle. You can look at that and look at the diagonals. And you could see that they add up to be the Fibonacci sequence, which I think is interesting. There's a lot of other applications as well. But here are the first 5 terms of each sequence. And now we have an understanding of what these numbers, what these subscripts mean.